14.3 Parabolas. We're going to be working through various equations, fully understanding whether they are going to be facing up, down, left, or right based off the equation, as well as starting to learn how to find the focus, as well as how to find the directrix from that equation. We're going to go ahead and skip to slide 4. In slide 4, this lays out all of our different equations that we are going to run into. We're going to begin with the left side equation. Now here, what's going to happen is that we are going to be given two different types of equations. The first one is y is equal to 1/4 p x squared, or you could also see it as x squared is equal to 4py. Now, generally, whenever you see x squared, this will generally mean that it will be moving up or down. Now, in order to tell whether it would be up or it would be down, that is determined by taking a look at the back end of this problem. Now, if it's negative, it would actually be moving downward. If it's positive, it would be moving up. In general, once we solve for p, that p will tell us whether we would be going up or down, and that p also tells us the focus. So notice, that would tell us our focus right there, and our focus would always be 0, p. The directrix would be y is equal to the negative of that p. Now, if p initially began as a negative number, by doing a negative of a negative number, you would actually end up with a positive p. This is where it truly depends on what is calculated on the p itself. We're going to go ahead and start with a sample problem. And we're going to start with the example of x squared is equal to 12y. Now, in this problem, we're first going to begin with by taking a look at the beginning part of our equation. Here this says x squared. So instantly we know that this would be an up or down movement based off that alone. We're going to compare it to our actual equation, which is x squared is equal to 4py. Now what occurs is that, if you notice, x squared and x squared mimic from our standard to our example problem, and so does the y. Now in this case, the only part that is left over is the 4p is equal to the 12 itself. What we're going to do is we are going to go ahead and solve for p. So in this case, 4p is equal to 12, which means p is equal to 3. Because p is equal to 3, this would go ahead and tell us that our equation itself would actually be facing upward. So this would be up. Now, from there, we're also able to figure out what our focus would be. So the focus itself would be 0, 3. The directrix would be opposite of that value. So y is equal to -3. Now, in this case, our vertex would be 0, 0. Let's take a look at the equation to the right-hand side and see how things change as our equations change up. Now, in this scenario, as you can see, we have x is equal to 1/4p y squared, or y squared is equal to 4px. This is an inverse of the equation that we just saw. which means that when we are seeing y squared, this means that our equation or our graph would be facing left or right. Once again, we would figure that by looking at the 4px. If it's negative, it would go left. If it's positive, it would go right. Now, everything occurs the exact same way. We're going to go ahead, we're going to solve for p and be able to figure out whether we are moving right or left. Now, because we are also doing the inverse of the initial equation, rather than it being on the y, we are going to be looking at it on the x, which is the reason why we see that the focus, or the p, is on the left side. Your directrix would still be the opposite of our p, but we would be looking at x equaling the negative p. So we're going to begin with our first example, which is y squared is equal to negative 6x. Now keep in mind, our standard equation is y squared is equal to 4px. We're going to go ahead and solve for our p. So in this case, 4p is equal to negative 6. P is equal to negative 6 over 4, which is the same as negative 3 over 2. So our focus in this case would be negative 3, 2, comma 0. Our directrix would be x is equal to 3 over 2. And our vertex would be 0, 0. Now, in this case, because we are ending up with p being a negative number, this would actually cause the equation itself, or the graph once graphed, to form towards the left, because it is going towards a negative. Keep in mind the example we are working on does not go along with the image above. This is a separate problem, but the image above does give you a better idea of what it would look like completely graphed out once it is graphed out. In the case for the example problem we're working on, we would end up having a rough image of our graph, or our parabola, facing the left-hand side, and the directrix being on the right side. And it would generally look just like that. Let's go ahead and take a look at slide 5. So in slide 5, the first thing that we're going to do is we're going to take a look at our equation. Now our equation says y squared is equal to 16x. So first thing, it's understanding that because we have y squared isolated for this problem, we would be moving left or right. Now, as we work through our problem, we need to figure out whether we are going to go left or right. Keep in mind, our generic equation would be y squared is equal to 4px, which means we're going to get 4p and equal it to 16. So p is equal to 4. Our focus in this case would fall as 4, comma 0. Our directrix would actually be x is equal to -4. Now, we are able to tell whether this is going to open right or left based on the number that we are looking at within the equation. Because 16 is positive, a positive divided by a positive would give us a positive, which means this would open towards the right-hand side. Our vertex would be 0, 0. Our focus would be 4, 0, as we had solved before. And our directrix would be x is equal to -4. For the axis of symmetry, it will always be based off of the variable that we are facing. So in this case, focus is on the x, directrix is x is equal to -4, which means it is the x-axis. That would be our angle. Let's go ahead and take a look at problem number 2. Here we have x squared is equal to 2y. Now in this case, this compares to our equation of x squared is equal to 4py. Now, keeping this in mind, this is going to tell us whether we are going to be looking at up or down. Now, in this case, because we are looking at a positive 2, we know that this will open upwards. Our vertex, once again, would be 0, 0. In order to find the focus, we need to set 4p equal to 2. P is equal to 2 over 4, which is equal to 1 over 2. So in this case, because we are looking upwards, keep in mind everything would be on the y-axis, which means we would end up with 0, 1/2 as our answer for the focus, and the directrix would be y is equal to a -1/2. We would ask ourselves, where do we find these values? The values are on the y, so the y-axis would be where the symmetry would occur. Let's go ahead and take a look at slide 6. In slide 6, once again, we are taking a look at our equation. It says y is equal to -x squared. Now, in this case, we're going to want to grab that negative and move it to the left-hand side. So this is going to look as -y is equal to x squared. Now, this is going to tell us whether it would be up or down. Now, as we take a look at our equation, we know that -1 is equal to 4p. We go ahead, divide by 4. So -1 divided by 4 is equal to p. Now, in this case, we know that this is going to be an up-down scenario. And in this case, we're going to be going down. Reason why we are going down is because notice it says -x squared. Because of that negative sign, it would immediately mean that we are moving down. Our focus would be 0, -1/4. Our directrix would be y is equal to 1/4. And our axis of symmetry would be on the y-axis. Let's go ahead and draw this all up. First thing would be, we are at 0, -1/4. That would be the focus. Our actual line itself would go wrapping around downward. And we would go ahead and find the directrix, which would be at 1/4. That is generally shown as a dotted line going in whatever direction it needs to go in, depending on whether it's on the X or the Y. Let's take a look at our next problem. In this case, we would go ahead and rewrite our problem as y squared is equal to negative x. Now, because we are working with a y squared equation, this means that we are going to be working left and right. Now, we need to go ahead and solve for p. So in this case, we have negative 1/4 as our answer. Reason why we know that it's going to be a negative 1/4 would be based off of our p0 or p comma 0. Our directrix, let me see. Our directrix would be y is equal to 1/4, and the axis of symmetry would be on the y-axis. Opening in this case would be down because of the y squared. Correction. In this problem, our directrix is not going to be on the y. This is going to be on the x. And the same thing would go for the axis of symmetry. It would be on the x, not on the y-axis. Because we have our equation here, notice the vertex would be off of our 0, 0. Our focus would be at negative 1/4, 0, which would be right here. And our directrix would be at 1/4. So it would also go right along this line as well. We would go ahead and graph that out. Let's go ahead and take a look at slide 7. In slide 7, first thing that we're going to do is go ahead and isolate our y squared. In this case, y squared is equal to negative 1/8 x. And remember, our equation is y squared is equal to 4px. So 4p is equal to negative 1/8. In this case, divide both sides by 4. And you're going to notice that our p is going to end up being negative 1/32. So our focus here, because notice we're also working with x, our focus would be negative 1/32, comma 0. Our directrix would be x is equal to 1/32. Axis of symmetry would be on the x-axis, and we know that based off of the points that we are inserting, notice they would be in for x. In this case, because we are working with a negative number, it means that this would actually fall left. Keep in mind, we have to pay attention to the equation itself. So this would be left. Now, if we are looking at 1/32, we go ahead, draw our 1/32. Vertex itself would be at 0, 0. And our focus would be at negative 1/32, comma 0. Let's go ahead and take a look at our next problem. Y is equal to 1/2 x squared. In this case, first thing that we're going to do is multiply both sides by 2. We're going to end up with 2y is equal to x squared. Once you try to simplify for p would be equal to 1/2. Now with p being equal to 1/2, we're going to go ahead and figure out our opening. In this case, it's either going to go up or down, but realistically, it would end up going up. The reason why we say that it's going to go up is because the 1/2 is a positive number. Due to that and us working with our equation, it's going to end up being a positive on a positive, which allows us to move right or just use that upwards answer. We're going to go ahead and solve for our focus. In this case, we have 2 is equal to 4p, which means as we divide, we're going to end up with 2/4 is equal to p, which is also equal to -1/2. As we start putting our answers down, notice our directrix would be y is equal to -1/2 x, or sorry, -1/2. Our axis of symmetry would be on the y-axis, and our focus would be 0, 1/2. We go ahead and begin drawing. Notice we're going to be on the 0, 0. From there, we also have to draw out the directrix, which is -1/2. Let's go ahead and take a look at slide 8. In slide 8, we have x is equal to 2y squared. We would first begin with identifying the equation itself. So when is x by itself? Well, that is generally going to be whenever we are looking at something that is left to right. So we're going to go ahead, isolate our y squared, which means 1/2 x is equal to y squared. Due to this, we know it's going to be left and right. Now, as we're taking a look at this number, what is going to happen is that we're going to end up with 1/2 x. Now, with 1/2 x, what will occur is that because it is positive, it will allow us to move in the right direction. So the opening would be right. Our next thing is going to be to solve for p. So in this case, we have our generic equation, which we are going to compare against. So in this problem, we have x is equal to 2y squared Now, as we're working this problem, we're going to go ahead and realize y squared is equal to 1/2 x. Now in this case, we have 1/2 Now, from there, we're going to go ahead and focus on our actual focus. So our y squared is equal to 1/2 x. our equation is y squared is equal to 4px. This would mean that 4p is equal to 1/2. We're going to divide both sides by 4, which means p is equal to 1/8. Now, because we are also going right and left, that means that our p, or our focus, would be on the x. So we have 1/8, comma 0. Our directrix would be x is equal to negative 1/8. Our axis of symmetry here would be on the x-axis. We go ahead and start graphing. So we have 1/8, which would be right there. Our directrix is x is equal to negative 1/8. So once we are at this point, we can go ahead and graph what we are looking at. So our line would start off at the 0 mark. Also keep in mind, the focus will always be inside of the parabola itself. So in this case, we're going up to 1/8, which would be roughly there. Let's go ahead and take a look at the next problem. We have y is equal to 1/4 x squared. So in this case, what will happen is we are taking a look at what is available. Now our generic equation would be y is equal to 1/4 p x squared. Now, since we have y by itself, this would be in the direction of an up and down problem. Since we're looking at 1/4, this would actually be up. We're going to go ahead and focus on the focus, which in this case, p is equal to 1. Now, the main reason why we know that it's equal to 1 is because the 1/4 p is equal to 1/4. So, with us solving for 1/4, at that point, our focus is going to be 0, 1/4. Directrix would be opposite. So in this case, because we are going up and down, we know that the directrix would be y is equal to negative p. Now in this case, our p is 1/4, which means it's a negative 1/4. And the axis of symmetry would be on the y-axis. Now, that goes over our various slides. If you have any question, feel free to reach out at any point.